when it comes to controlling Arduino using Bluetooth device, then HC05 Bluetooth module is the most cost-effective hardware. The HC05 makes communication super simple using Bluetooth SPP, which is a serial port protocol. This means HC05 module communicates with Arduino via serial communication protocol. This means it uses TX, RX, VCC and ground pins. There are total 6 pins on HC05 Bluetooth module. The first pin is enable pin, which is represented as EN as enable. When enable pin is pulled low, the module is disabled. And when enable pin left open or connected to 3.3 volt means a logic high, the module is enabled. That is how enable pin makes sure whether the module is on or off. VCC is a supply voltage. This is usually connected to 5 volt DC. Then comes the ground pin GND, which is a ground. TXT is a transmit data pin, or XT, which is a receive data pin. Then comes the last state pin. The state acts as a status indicator. When the module is not connected with any other Bluetooth device, the signal on a state pin goes low. At this low state, LED flashes continuously, which means the module is not connected or paired. When the module is connected or paired, then the signal goes high on the state pin. At this state, LED blinks a bit slower. Apart from these pins, there is one button switch. This usually used to switch the module into AT command mode. To enable AT command mode, press the button switch for a second. We have to hold the button switch for a second and then our device will go into AT command mode. Using AT commands, the user can change the parameters of HC05 module. So if you really want to dive and change the settings on HC05 on the lower level, then you probably want to use AT commands, but that's not a scope of this lesson. Let's look at the software features of HC05 Bluetooth module. If you know that the Bluetooth works in master and slave communication, so the HC05 Bluetooth module comes by default as a slave device. So the slave default baud rate of HC05 is 9600. It supports auto connect to the last device on power as default. So whenever you power up the device, then it will automatically connect. So if you have HC05 connected to any Arduino or any other device, and when you power up, it will automatically connect to the other Bluetooth device. So you need not have to reconnect every time. It supports power on default, auto connect feature. Then it also supports auto pairing feature. So because before we make the communication work with HC05 and Arduino before we make the communication of HC05 of an Arduino with a mobile phone, we have to pair these two Bluetooth devices. The Bluetooth of Arduino, which is HC05, and Bluetooth of a mobile phone should have to be paired, and then only we can use them to control. Okay, so auto pairing feature, will be available with HC05. It does support by default. So whenever your device gets powered up, then if it's been powered already, if it's been paired already, then it will going to connect straight away. Okay, and the default pairing pin code is 1234. You will going to see in the future lesson where I will show you live how to pair the Bluetooth devices, right? Especially HC05 with your Android phone. We will only using TX, RX, VCC and ground pins. Just only 4 pins we are using on HC05 module. The rest of our functionality will be covered in some other Bluetooth specific courses. The objective is to keep lessons simple and straight to the point. Please note that HC05 doesn't work with iOS because iOS only supports few Bluetooth profiles. This is because actually Apple uses M5 licensing program and HC05 doesn't participate into it, so it doesn't support HC05. Bluetooth module. That's why in the end we will only create an Android app. In the end of this section, we will learn how to create Android app and control the LED connected to Arduino Uno using smartphone or over Bluetooth. This entire project or the task is a 4-step process. The first step is basically to write an Arduino program. The second step is to make a connection between Arduino and HC05 Bluetooth module. The third step is to create an Android app using MIT App Inventor. And the fourth and final stage is to send the APK file, which is an Android package kit, the Android app, to our smartphone. And then later on we will going to test on the real smartphone whether we can really able to control the LED connected to Arduino Uno using the Android app. So that's how it's going to be. I hope you will find this video educational and entertaining. We'll see us into the next lesson where we will going to set up the connection and write an Arduino program and do the further processes. Thank you very much for watching, and we'll see us into the next lesson. Bye bye.